Okay, so technology played a bit of a part in today's lesson in making it a bit confusing, so sorry about that. So if you were just a little bit shaky and couldn't remember some of the stuff from last year, not a problem. So just go through this. We've got find the height of a flagpole, which casts a shadow of 9.32 meters when the sun makes an angle of 63 to the horizontal. So drawn the good old right angle triangle. This is obviously, this side here is our flagpole. Okay, so that's what we want to find. We'll put a nice big old X there. It casts a shadow of 9.32 meters. So, oops, don't want that. The shadow has to be on the ground in this case. Okay, so 9.32 meters is going to be there. The sun makes an angle of 63 with the horizontal. So clearly the horizontal is along the bottom, and the angle rays are coming down. So we're going to pop the angle there, right? That one in there is the 63 degrees. So remember what we talked about in class today, that we've got some pretty clear steps always, right? We're going to label our sides. This is our angle, which means this is our opposite. There is no hypotenuse in this case. Well, we don't want to find it. There's no information there. And so this is the adjacent. So that leaves us with tan. We like to write the rule. Okay, and then once we've got our rule, we want to substitute our information in. So tan 63, your opposite is the X, and your adjacent is 9.32, and it's a simple matter now. Let's get rid of the divide by 9.32 and times. So 9.32 times tan 63, and I'll leave you to work that out on the calculator. Making sure that your calculator is in degrees. So just in case it was a bit too quick or you missed it in class, obviously with your graphics calculators we can see right at the top screen, you can see a little DEG there, so we know we're in degrees, which is correct. If it's not, shift setup. Okay, you can see, we'll scroll down to angle, and we've got degrees there, which is what we want. But sometimes if someone borrows your calculator or it resets, it will switch back to radians, and that will actually give you the wrong answer, and we'll discuss that a little bit later on as to why that is. But we want to just press F1 underneath, right? Degrees, press the F1, it changes into degrees, and then you press exit. So there we have it, and press enter. So the height of the flagpole is 18.29. Okay, and now let's have a look at the next one. So I'll just stop it for a minute while you read it, and I'll draw my triangle. Okay, it's all about reading the question and labeling the triangle. Now, if you read the question incorrectly and you label the triangle incorrectly, as long as you then do the correct calculations for your diagram, you're not going to lose all marks. So this is where you really got to make sure you show as much information as you can. All right, even if you think, I know this like the back of my hand and so simple, it's so easy to make easy mistakes, and you just don't want to lose marks when you don't have to. So we've got a hill. Let's imagine this big thing here is the hill. It's inclined at 18 degrees to the horizontal. So we're going to pop 18 degrees there. If the base of the hill is at sea level, find my height above sea level. So we want that. If I walked 1.2 kilometers up the hill. Pretty nice. So we go through the same routine, and it does become that. It's a routine. Okay, we label. By now some of you, or even before you did this, you could just look and see what the rule is. So that's your hypotenuse. That one's opposite. There is nothing on the adjacent. We don't want to find that length. There's no information there, so it's just down to O and H, which is our sine rule. So we say sine theta, opposite over hypotenuse, and then sub away. Okay, so it's sine 18 equals x over 1.2, and once again it's just like the question above, except instead of tan it's sine. So to get rid of the divide by, we're going to times. Okay, so check it on our calc. 1.2 times sine 18, right, gives us 0.37, let's go to 3 decimals in this case, 0.317. Oops, forgot what it was. 371. Oops, 371. And if you look in the book, in the back of the book, you'll find that the answer is slightly different. And this is where you don't have to change your answer as long as you have written kilometres. So if we look at the answers here, it's got 370.8, which is what we had, but notice this is metres. So you don't have to, like it didn't say, express it in metres, whatever, so this is quite fine. Okay, let's have a look at part B. How far I have walked up the hill if I am 500 metres above sea level. Okay, so I just redrew the triangle. So the angle is still the same, so you've still got the same road, but this time we are 500 metres over here, and you want to now find out how far you have walked up the hill. So same deal, label your triangle, that's still the hypotenuse, this is still your opposite side. So once again, we're rocking sine theta. But this time, when we substitute our information in, the angle's still 18, but this time our opposite is 500 and our hypotenuse is x. So, dun 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 dun, this is one of those examples where your unknown is at the bottom. And so hopefully we all recall that that's when we do the switcheroo. So we switch and we say, therefore x is 500 over sine 18, and off to the calculator you go. So feel free, pause the video, do what you want. You might feel confident now to go on with the next one, so pause it. You don't have to listen to me bore you anymore. I'm going to keep going just to amuse myself. Okay, let's have a look at the next one. A surveyor standing at A notices 2 posts. The posts are 120 metres apart. Okay, it's labelled. Very often you're probably not going to get a diagram. You will just have to draw it yourself. So get used to reading the question and then creating a diagram. The angle of sight between the posts is 7. How wide is the canal? So here's the canal. Now be careful, because we don't want that one. We're not wanting the length from A to C. We want how wide the canal is perpendicularly. Great word that is, perpendicularly. All right, so we've got opposite, right? Hypotenuse, that means that's adjacent, but no information, don't want to know that length. So our friend, tan, feeling a bit sorry that we haven't used poor old cos yet. Anyway, tan theta is opposite over adjacent, and let's pop our information in. So we've got tan 37 equals 120 over x. Hello, unknown is downstairs, so switch x equals 120 over tan 37. I'm run out of room, just because I didn't do the other one, we'll do this one on the calculator. So 120 using my fraction key, tan 37. Bang. Don't forget to put your units. Hoping that they were loving the trigonometry. We've got now a train. A train is climbing a constant gradient of 5.5 for every 200 meters of track. So let's make our right angle triangle. Oops. Not wanting to play games with me. It's decided to stop working. Sorry about that. Okay. Oops, there we go. That's a bit messy. Okay, I have to read questions like this one a couple of times, so just have a think about it. But a train must climb a constant gradient of 5.5 for every 200 meters of track. And you're going, well, where is the track? So is the 5.5 here, here, or here? So 200 meters of track, think about it. The track is the thing that is going up the hill. That's where the train is going. So that's your 200 meters, right? And it's climbing 5.5, so it's going up. So that's your gradient there. All right, once again, and it's all in meters, so we're okay. Once again, if you're unsure, make sure that you put something on your diagram, and at least you can go from there. So find the angle of incline. So that's that one. Okay, poor little cosine is not going to see the light of day for these first 4 questions because we have got opposite and hypotenuse, which is once again our sine. So sine theta, opposite over hypotenuse. We've got sine theta is 5.5 over 200. How do we get rid of the sine? Oops, let's get rid of that. We say theta is sine to the minus 1, 5.5 over 200. Okay, and then we go over here, so it's shift sine, there's your inverse. Love these calculators. Use your fraction button. You don't even have to put the brackets in. But look, if you want to put the brackets in, go for it. It's not going to make a difference in this case. So it's a small incline, 1.58 degrees. So clearly an exaggeration in my diagram, but there you have it. Okay, so hopefully it's eased you back into a little bit of right angle trig. You'll get lots more practice as we go.